and also being in several boards. He's also now in the advisory committee of the University of Clausthal.
Yeah.
And particularly important here is that during the time at Scania, you also were the driving force in getting ITRL to exist. So this is the founder of ITRL.
Not the founder. One of the co-founders. We had a strong team, you have to say. Yeah.
And also, you are the honorary doctor at KTH.
Yes, it's a great honor.
At Clausthal, I believe. Or
no, a professor. Yeah, honorary professor and associated professor.
Yes.
There. Yeah. Mm-hmm.
And you're here to talk about the future challenges and possibilities in digitization and connectivity.
Yeah.
So we're delighted to have you.
Thank you. Thank you very much. Jonas, thank you very much. Good morning, ladies and gentlemen. Först tror jag kan prata svenska och ha en presentation på svenska, men sen jag sett att it will be mycket bättre to prata engelska. And as I know, we have also some people out in Poland, I think you said. Maybe also welcome when it comes to the live stream and they have switched to the presentation. First of all, I must say it's a great honor for me to be here and to have this presentation. And it was also a great honor for me yesterday to be in the jury of Pedro Lima when he had his defense. And I'm very astonished you're being here now. Even you had I heard a very nice party and you celebrated your doctor title and you did a good job also once. And it was a pleasure also to read your thesis once more again. You did a good job and I'm very proud that you are now working at Scania and bring the autonomous driving much more a step forward. And I think we need it. And when I reflect what could be a theme to talk about, and I recognized, let's talk about digitalization and connectivity. These are being new possibilities, but they are being also challenges for the automotive industry and also for the academia. It will be a question how we will work and on what kind of themes we will have research in the future. And this will change a little bit. And then suddenly some thoughts coming up and said, oh, wasn't it the same idea when we founded ITRL, as you said, Jonas? We said it is an integrated transport laboratory. We have a transport laboratory at Scania. They are testing trucks and trailers and trying to get a better flow in the transportation. But how we can integrate, because we have different shareholders, the cities, the customers, the law, which gives restriction to the transportations, or can we even open some of the restriction in the transportation? Can we make it easier for the logistic companies? We have the society. Will they accept autonomous driving? Will they accept another delivery? So we have to bring all the different stakeholders together and work on future transportation. This was the idea of ITRL when we have signed it in 2014. And the idea in 2014 was, as you can see, future potentials for carbon dioxide reduction as an integrated transport. So we focus a little bit more in the benefits to get fuel consumption reduced. Today, we are thinking another way. We are thinking a little bit what kind of other methods can we have that we can make the transportation more sustainable and even more effective. This is the idea. And we recognize today the passenger cars. This is also some picture which I've used in the signing ceremony in 2014, that we recognize the car manufacturer comes more and more to the mobility provider, and the truck manufacturer comes more and more as a transport manager. Some steps has been done in the meantime. Scania has lots in Scania and in Stockholm working, and Scania started up these ITRL issues. So I said, oh, it's still valid. Even it's something about 4 years ago. And then you could recognize that the automotive industry is in a fundamental change process to be a part of the future transport solutions and mobility providers by using the possibilities of digitalization and connectivity. And for me, my picture is the connectivity is the key. The digitalization enables the connectivity much more easier. So when you have data available, then you connect much more easier the processes or people or the information. And questions which going around, you can read it in newspapers, in publications, or see it on ferries. Do we believe in the future of combustion engines? Do we think about that in the future we will still run on combustion engine? Or it is poor electric-driven vehicles in the future? But what does it mean when we have only electric-driven vehicles? I don't know who from you have followed up in January this year when I said East Europe, a country had a high demand on electrical energy. And suddenly in Germany we recognized all our electric watches on the railway station were going wrong. And we didn't find the root cause, and we find out. I know exactly, it was Litauen or it was Bulgarian, I don't know exactly. They used a lot of energy on one source, and suddenly the grid and the energy distribution were disturbed. And the frequency was not any longer 50 hertz. It was something about 47 hertz. And this has an effect on our electric watches. And we know when we will have, we made this study in a class time, and we have a special amount of electric vehicle. And we take the worst case when we have more than 1.5 million electric passenger cars driven, and we are looking on the worst case that at the same time these 1.5 million vehicles will charge the batteries on the same phase. You know, we have 3 phases in the net. On the same phase, even the angle between the 3 phases will change. This will mean that an electric engine will not run smoothly around. If you go in a drilling machine, you will recognize suddenly that the drilling machine makes and then stops, gives a high speed, low speed, and you will not recognize maybe in such a big effect, but there's something which influence. So preparing for the electromobility, you must also prepare the grid of electricity for that. And the grid even today with the windmills, which is also very dynamic, is also affected by these kind of sources for electric energy. So you have also to find some other methods. Think about if you have a big generator in the past making electricity, they have such a huge inertial mass. And you put some electrical consumer in the plug. This big inertia mass doesn't take care about that. It's running. But if you have some wind energy and windmill, you get a lot of peaks in the grid. So this has also some influence for that. We have to talk about that. And the other thing is also, believe we are in a better traffic organization with an optimized traveling time and routes and inner and outer city. When you ask this question, you get immediately the answer, yes, it must be possible. The first questions are a little hesitating. And we will believe in an autonomous transport solutions. I think yes, we will believe on that. Otherwise, Pedro would not have done his doctor thesis. And the question is, will we believe that we will use also the air as transportation ways? Do you believe that you get your parcels by an octocopter or by a drone? Will this happen in the future? These are being questions. And we have some ideas, but a real answer we don't have. The only thing what we have, and this is a picture from still valid in my opinion, it is from 2014. There you can see that the transportation of goods, especially in Germany, this was a study from the VDA, an association of the automotive industry, will grow from 2010 until 2030 up to 39%. And then you'll see the main part of the transportation will be done by on the road, by trucks. A smaller way will be done by the railway, because it's 7 times more expensive to build up a railway, and only a smaller part will be done by the ships. So it is something like that 70% of the increasing transportation volume of goods will be done on the road. So, and if you go to Germany and you look, for an example, the highway between east and west, this is a row of trucks. On the right lane is only a truck lane. And if there's something happens, it stops. And this is something you have, something like a continuous flow you should have, but you don't have. So we have to do something in the planning. The reason for this increase of the goods transportation is something that even the B2C e-commerce, especially the buying things in internet, increased dramatically. See about that from 2010 till 2016, we have doubled the volume of delivering and ordering in the internet. These parcels were brought to you at home. There's a delivery chain. And mostly 50% of this, which you have ordered, gets returned. Because you have the choice at home to take these things or not. So you have also not doubled the volume of goods, you have also doubled or 4 times the transportations. And on the other hand, looking for my last work was in the light commercial vehicle areas, you could recognize that on the one hand, the transportation is squeezed between the customer demands and the legal demands. On one hand, we have an increasing to the end customer deliveries by B2C or e-commerce. Your expectation is when I ordering in internet, I would have it on the same day. Same day deliveries is something what Amazon and other warehouses aiming for. And when you're looking at the customers, they would also have an optimization by the payload or by the volume or weight. And on the other hand, you have the legal demand that the emission target should be fulfilled, especially in the light commercial vehicle. The NOx or the real drive emission testing will coming up. If you're not fulfilling the carbon dioxide limits in 2020, you have to pay 95 euros per gram, each gram, where you be above 95 gram carbon dioxide per kilometers. So when you have a higher volume of cars, you can pay billions of euros to the European community for penalty. And we have also getting more or less restriction in inner city because about the low emission zones. Cities would like to have lower emissions and having a better living standard, because a city is nothing else than a company. The product is a good living environment, and for that they are getting taxes from the inhabitants, so automatically they are looking for that. And we are getting also more and more restriction on night traffic. And in the middle you have also the competition of the logistic companies to minimize the costs and to get a better total cost of ownership. And when you're looking for an example a little bit back, in 2008, you had about 267 prohibition in 247 cities in Europe. Prohibition to go in the inner city by a lower emission standard of the vehicles. In 2016, you had about 511 prohibitions in 423 cities. And this is an increase about 90%, really nearly 100%. The restriction to drive in the cities are growing dramatically. And these kind of rules are growing. And I like this picture also to reflect sometimes about rules. do we need always the rules, or can we also avoid rules because it's also very efficient to follow something? And looking for an example, this is a traffic sign. Every person who is driving a car in Germany should know that. This means, what do you know? What do you think about? What does it mean? Yeah, an animal can cross, it gets awareness an animal can cross the road. Do you know in Germany we have two of them? Because the animal can come from the right side, but the animal can also come from the left side. This is Germany, because you should know that. And our government maybe have not many trust in the people that they should know that. And I must give a compliment to Sweden. I think you have only one. And I don't know really now if the elk really always come from the right side. Maybe he comes also from the right side. But the government gives you a little bit more trust. You should know that. And when you have such more or less complicated rule, you must also take aware that you can mistakes with the rule. Because when you go to Lindau on Bodensee, and it's a highway 96, some of the workers have done a wrong way, that they installed the traffic signs. So this means the animals running away from the road. There is no dangers. But it is really a mistake. And whenever you would drive to Lindau, it is round about Memming. There you can identify this traffic sign. This is an example, to think also about the rules. And as a company or logistic company, you have to reflect on that and also to work sometimes. Another example is also, oops, sorry, it was wrong. Another example is also in Germany, when you're being in the fire department, you have a regulation. Whenever you're crossing the pipe, the hose over the street, you should use some of these protection. And it said, whenever you're crossing a way of traffic, you should use these kind of protection for the hose. And someone did it really consequently and said, okay, I will do that. And at least you should also sometimes reflect, not every invention as an engineer you are doing is well functioned in every time. For an example, we had opened the automatic open trunk lid, but then we recognized it is nice to have it in summertime, but sometime in the Swedish winter it could be some negative effects. So coming back to, after this reflection, what is the typical delivery scenario? First of all, you get raw material in the factory. You get some parts, some components delivered to the factory. Some work is done in the factory. Then sometimes you're going out with some parts to get some special production or value-added processes by special companies, which you're not doing in your own factory. Then it is delivered back. Then some of the products being produced or assembled in the factory. Then the factory comes to a store, the products. Then they come to the dealer, and then the end to the customer. And every step of today is done separately. And every step is done by their own and is tried to optimize themselves in the local frame. The question will be in the future how we can steer or can optimize the process when we have some cloud data available around the world. Can we also optimize to avoid empty trucks on the road? Can we optimize the load or the use or using the space on the truck in deliveries? This is also one of the essential questions. And also can we by that avoid additional traffic? And the challenges in the automotive industry, and this is a picture from Mr. Jungwirth. He is Chief Information Officer in Volkswagen. He is also looking about what will be the digital disruption and transformation challenges in the industry. And it is something in the sustainability. This means for him electrification. It is a challenge in the urbanization with shared mobility concepts in transportation on demand. And it will be the self-driving systems with the connectivity and autonomous driving. These are being the three main challenges in the automotive industry. And there is the risk that one or two of them will be done by other companies, by other organizations, and maybe will also disrupt the role of the automotive industry of today. So coming a little bit to the electrification, you know that especially in the light commercial vehicle, it is done, or it was an electric-driven, battery-electric-driven crafter produced. You could see that this crafter, with a capacity around 30 kilowatt hours is consumption, and it has, as I know, something about 40 kilowatt hours as a storage. This can run about 150 to 300 kilometers. It depends a little bit about the landscape and about the topography. It should not drive faster than 100 kilometers per hour. And this is a concept we build up very quickly to be in the lead for also for offering our customers some battery-driven electric vehicles, especially for the cities when it comes to deliveries. And you can also see when you compare that with the bus operation for electric-driven buses, very important is that you have something about 20 kilowatt hours per 100 kilometers. This means 0.2 kilowatt hours per kilometer, and it's roughly 5 times more in a bus. And this is only the energy you need for transportation. But on the bus you have even special equipment, so you will end up to 2 or 2.5 kilowatt hours per kilometer. What does it mean in the consequence? Electric-driven vehicle, if they will have success or not, is the question of the storage of energy and delivering the energy in the right time. This means you have to charge these vehicles consequently. To have these charging possibilities, you must have charging stations. And if you look, these are figures in Germany. In November 2016, we had about 5,700 charging stations in the whole countryside of Germany for charging. 5,000. It's not good. At least we calculated to have a flow in this charging, you must have something more than 150,000 charging stations. And when you are talking to the energy companies, is this possible? They said, yes, it's possible, but unfortunately to 2020 and the following years. So what we have to do really is, when promoting electric-driven vehicles, we have also force or promote the building up the charging station and the energy distribution. Otherwise, we will have an amount of vehicles, but we have no possibilities to charge them. And another question, and this is something what you could also observe, especially in the area where I'm living now. I have a hybrid Golf, and when I went to the city in the morning, I recognized every day at 7:30 the same car is parking on the charging station. He has plugged in his car, and it is plugged in until 4 o'clock in the afternoon. This is not why he would like to charge his batteries, maybe the first 2 hours, but it's a free parked place. This kind of driver is recognized by charging on a public charging station I have a free parking. So, and I asked the major, what should I do that I can also use this charging station? I said, I have no instrument. How should I know if the battery is full or not? And there we're coming back to this theme that we have, digitalization. Why, and this is my question, isn't it possible to give a signal, or even when he starts up charging the battery-driven vehicle, your battery will be charged on estimated time in 1.5 hours. Then you have a tolerance for half an hour, but then you get a ticket when you're not leaving the charging station. This is not organized. It could be organized, but how? You have to share data. And the data will be available in the time of digitalization. This is something which we have also think about. It depends on some new methods, but it also depends on some new rules. We talked about rules. We are very well done to invent 2 traffic signs for animals changing or crossing the road. But we are not able to find some rules how to handle with the capacity of the low capacity of charging station. And this means, and there I'm being back to ITRL, this was once they thought about for founding the ITRL, how we get the stakeholders together to understand each other, bring up a network, a grid with energy supply for charging station, bring up an organizational rule from the politics or from the law, how to handle this charging places to make it available for a wider customers amount. And these are being the next steps we have to think about. And who gives the impulses to that? Today, I think many of these necessary changes are not seen because everyone is optimizing his own part and not the overall part. Fleet owners will have it much more easier because they know exactly when the fleet has to be charged and how to handle it on the, let's say, on the logistic area. They will have it much more easier to continue for that. And this is the reason that we are working more and more now on the connected van. For an example, for the new e-Crafter. And I can also tell you that we were now successful with an institute in Germany to work on a van assist application. This is something what I observed also. For an example, when in a small village where I was living, there is a distribution center for the post. Every morning at 8 o'clock, people coming up, sorting out the parcels, looking on the address, having their route in their mind, and saying, okay, I will take this parcel later. I think this parcel I will deliver first, put it on the first row. And they sorting out the parcels and loading the vehicle. And this is mostly between 8 o'clock and 10 o'clock. At 10 o'clock, the driver starts sitting in the car and delivering parcels. But every parcel has a digital code which can be scanned. And my question was, why should it not be possible that it's done overnight, automatically? The driver comes in the morning, switch on the navigation system. The navigation system gives him the route, the stops where he has delivered. He has something not to work 2 hours in the morning for sorting out parcels and loading his vehicle. And then we calculated up how many of these central delivering distribution centers the post has, how many people working with that, every day 2 hours, how many hours it will be in a year, and we ended up by billions of money which the post organization can save. And then I asked for them, please give us some of them, only a small part of one, for research to make a concept how we can do that. And they were convinced after, you can see 3/4 of a year, after 1 year, roughly 1 year, that okay, yes, we should do that. Even the decision takes a long time if you have an idea. And I think this is something when you're following now the ideas that the digitalization and the new business models and the working place like the ITRL will help to implement a new infrastructure for a better operating system. We need such elements like the ITRL. Because here, and this was the idea, you can get in the different stakeholders on a neutral place to work, not out of competition, and to see the overview picture about that. And it's always about that we have the right methods, the infrastructure, ICT infrastructure for cyber-physical systems, and regulation and programs that we can really enable these fundamental changes. This is one of the main questions. And this comes up to a picture that we said we must also take aware when we are using the digitalization that we are using it in the right way. And I show it a little bit on a concept, how the controllers are used in a vehicle. When starting with the first controller in a vehicle, we had a controller with software and models in one package, in one something like closed installation. Then later on, we put some elements out, we put some elements on top, and we improved the software and especially also the models, how to control the vehicle. Later on, we continued, we add on some, but we also take something out. And when we are being at the new generation of control system in the vehicle with more than 100 different ECUs, control units, with different additional software, it is an evolutionary development. Then we recognize a little bit more or less it can be unstable because we developed evolutionary. And the risk will be that once a day software and the models will collapse. And this is something we have to avoid. And by the way, today we are using all the methods based on a single processor. The method in the computer industry are being even more. We are using double processors, but this means a new software. Everyone wants to avoid to make a big step between a single processor software to a double processor software. And therefore, we are so happy that we could develop as evolutionary, but we don't know exactly how stable it will be. And this is something which we are looking now, and where I'm now a little bit motivated to continue, is the quality of documentation, models, software. This is essential for the actual product. We recognize it. And this is shown also in this picture. When we started, it was something like that the essential complexity was quite small, and the additional complexity also small. So we had an easy walk. But in the meantime, the essential complexity, the real steering and controlling task is still the same amount. But the additional complexity we have with the connection of the data is growing. And this is something we have also to learn in the development, because how many times in the controller or the models we are using by organization of data or by connecting different controllers and control units together, and how less time and capacity of the computation we are really used for the real model or for the real controlling. And another issue is also how we should develop in future these kind of software. Everyone is aware about the V model. You start up in the development, system engineering, you make the function development, you make the software. This is the development, and then you came up in the evolution and give them a special release of the car. In the agile software development, you're working more or less in a circle. You're starting up with the software engineering, you came up with in the team, you're making a testing, you make an improvement, and you make an implementation, you make an improvement. You're running like in a circle. And you're using by that even the network. And when you come later on in the development operation model, you really went out from a test. In the real life, you observe your data, in the running operation. You have an open access to the data. You can improve the program, and you go back in a test phase, and from the test phase automatically you go back in the operation. So with the new DevOps methods, the development operation methods in the digitalization laboratory, you can be much more faster in new models. And you must be faster. Think about if you would like to make a total change in the system architecture of steering control units in the car, you don't have time for the next 30 years. You must do it in a very small step. And this is something where people having now started up research, how we can do this development and operation development of software and steering much more quicker, much more faster, even to the customer. And this will be enabled if we have an open access to the customers, to the vehicles, to the trucks. But with the open access, we have also some open risks. That's clear. And a special element of this is something when you're looking in a factory. If you have one failure, a worst case in the production system, you know it gives an alarm. You see it on your monitor. But this also affects another and another and another failure in the production system. And when you're being now in this situation and you're being the controller sitting and have the control about the production system, you don't know really where to go to the first, who is the root cause. If you would like to run the production much more properly, you have to start quickly to find the root cause. But when you have so many indicators, you don't know exactly where to run. Even this is a method we have to think about how we can, for an example, when we have a fast development, how we can also during the software development give also some hints to find the right root cause if a failure appears, to be quick to solve the problem. This is some research activities in the University of Clausthal in the Institute for Informatic and Cyber-Physical Systems. And this is something like we should come on and something like, you know, when you have a copy machine, it's very intelligent. If there's some failure appears, it gives you directly an advice what you have to do. And this we have also to think about how we can implement it in the future system. And this means we will come up to a new organization of the data. We will get, for an example, when it comes to transportation, fleet data. We have the data analyzing in the database. We will have then afterwards operating strategies. Then we will have a predictive control for driver and vehicle when it comes to semi-autonomous driving. And these results of the vehicle later on will come up in the database and will improve the data analyzing. These are being some methods. Today, we are starting with that in Digitalization Laboratory, really to start up and to see what will happen. And you can see, especially when it comes to cyber-physical systems, it's in German, excuse me, but if you have not also some safety and security built in these software, you can see that some hacks or some effects on the software bring you totally wrong information. Even today in the internet, if something written about you personally, you don't know that this is running around the world in seconds. And you are not able to capture these wrong messages out. And therefore, this is another research area we have to take care about, how to meet the security demands when it comes in the operation of complex function. On the one side, you get signals in from sensors. You have some pre-processors. Then you have machine learning function. You have complex function. You have the complex function running around here with sub-functions. And then you go out in the actuators by post-processing and delivering signals to the actuators. And the question is how we will ensure all the activities in a world or in the environment to be enable that we have a higher security level in these functions. Yes, you can take some fences around the sub-functions. You can say, I'm absolutely sure I make some investigations before I starting to calculate and to make the models. I build a fence, but this is not the best way. Really, the best way is to find gauges around each process. And then you will be able to bring up a big fence really to ensure security. It is something like in your living area. You can build up a big fence around your living area and hope that no burglary will steal your belongings. But you also can do it both. You can have a big fence around the surrounding, but you can also have a fence around your house. Then you have double security. And how even these security affects each other is not well known today, because too much security will also give some negative effects on the speed of the calculation. And speed is essential, as we learned also yesterday from the Pedro. You must really try also to simplify some of these functions to be calculated online. Yeah, and especially when it comes to driver assistance systems, it is something that, especially in the testing, it becomes more and more a critical phase. We have no answer today, and this was a question I was also asked yesterday to motivate a little bit to think about how many times we have to go to the test environment when it comes to driver assistance systems to be sure that these test driver assistance systems will function under each conditions. I got the question, if I couldn't give an answer, how many kilometers a car autonomous car must drive that we can release it off a public road. I have no answer. I said it must be something, how many different situations you have seen in the control unit, how many different situations you will have. And then I got the questions, what kind of situation we should have, that critical situation. But what is critical? I don't know. As much as possible. And then we tried up to calculate a little bit, and we came up at least to have an amount of situation tested in an environment. You must drive something more than 4 million kilometers with the passenger cars. But the passenger car will drive most likely 200,000 kilometers, and it will break down, or maybe 500,000 kilometers, and you have some problems. How this relates? We have a problem. We recognize. We have a problem how to get knowledge about the functionality of software, of controllers over lifetime in different situations. It's a big field of research we have to do, in my opinion. So we started up here. This is only one institute in Germany. I hope many of these problems will be known by other research institutes, and together they will work on these themes, and someone will find a solution. And we made also some statistic when we made different testings around that. And here you could see this is a simulation database. This is the proving ground in Wolfsburg, and this is the public highways. And you can have a look on that, especially what percent correct tested, what was not incorrect tested, was correct, not correct, and what was correct, but it was not tested, and was not tested and was incorrect. And even looking to the last figures, 2%, which you from the not tested area was incorrect. So what we have tested, we found out everything what we have tested was correct. Really, here we would like to go and give a release. But then we recognized now some situation which was not tested in the test lab, and from this 96% was well done by the controllers, but 3%, 2% was incorrect. And even these 2% is too much in real life. It could be an accident. And this is something we have also to think about, how to change then our organization to make a step forward. In the past, we had to focus on the parts. Someone was responsible for the steering wheel, someone was responsible for suspension, someone was responsible for the engine, someone for the seat. And then suddenly we recognized function coming in. The seat is preheated, the steering wheel gets some electronic knobs, and the engine gets more and more higher control. So then we recognized these functions were not ready at the same time. We need an organization that we will be stepwise improve the functionalities of these components. And then we recognized now we would like to drive autonomous. And this is a folio from BMW. They started up in the last half year to find a new organization in the development. You can see with Scrum and Scrum Masters to be very fast away from the component-oriented development, much more to Agile component. And here we have a problem because the law don't accept this. You need, against law, one responsibility. And nobody is that in this Agile, Scrum Master-oriented development. Coming back to ITRL, is ITRL something where we can test these kind of new elements? We should. And this is something we have also to bring forward, even to the industry, that is absolutely necessary to work on that. I'm totally convinced. ITRL started in 2014, and they should continue. It is absolutely necessary to go forward in these and to bring new impulses for the industry. And I always can give the recommendation, please continue for that and show to improve what we have to do. So we have some trends and challenges. We have the transformation. We have to use the digital laboratory. We have higher complex product variants and high pressure to the cost. We have the system evolutions. We have an open and secure connected mobility service on the cloud. We have to think about how to bring safety in the connectivity in the cloud and the data management. And we must have safe and secure autonomous intelligent vehicles. We must have a field and data-based validation combined with the concrete methods and verification. Some work has to be done. So nobody knows exactly how the future look, but next time I don't know how I will raise that till I get you home. Thank you very much for your attention, and I hope it gives you some inspiration.
Thank you very much, Harald. So now we have time for questions, and in the interest of those that listen online, if you could repeat the questions from the audience or rephrase them, maybe.
Okay.
So do we have questions? I can start with one question.
Yeah.
Then. So we talk a lot about how so share connectivity and data will change the businesses. And we also see that the private data is very easily shared. Everyone is willing to share data. But my experience when talking to industrial players is that they are still extremely secretive with the data. Is that changing, or what's your perspective on that?
I don't expect that this will be changed, because the data which the companies have, it's fundamental for the business. In your private data, sometimes it is also misused, be honestly. Sometimes when you're going to internet, suddenly you get next day some advertisement for photography because you have looked for a nice photograph picture or something else. So it is sometimes misused, but you can handle this. But when the data or the availability of data is essential for your business, you're being more restricted. You would like to make some contracts with your partners. Please tell me how you share my data. I would like to know how you share your own data, and when you're giving me the data, can I believe the data? And Jonas, I think this is something we have to think about. Next to the technical, we have to think about some to get some rules, or even some new business models, some new laws to to give us respect how we can handle data. If you rent me your car, we sign a contract. I have the obligation to bring it back in the right order. Otherwise, I have to pay for the damages. This is something we can contract. But if you give me data and I give you the data back, you can't check it if I have done something with your data. Or how to prove, how to get quality. If you give me your software and I use it and I modify it and give it back, you will find that I have modified the software. Who is able to give me an instrument where I can check the quality of a program? If, for an example, let's say a controller is programmed, is this on a high quality level, on a low quality level? With a piece of metal sheet, I can go to the quality department and please measure it. And you get immediately what is the tolerance about the component. But nobody shows me what is the tolerance of the software. You know, we are missing quality instruments and we're missing also some legal instruments. And this is something you have to propose and work on it.
Hey, Anna?
Yeah,
Anna?
thank you for a fantastic presentation. I think it was one of the best in the field I've ever heard.
Thank you.
I also want to know a little bit, because you didn't mention Ericsson, and Ericsson is also part of the partnership with ITRL. So
Yeah.
just wanted to know what your hope is with the partnership with Ericsson in ITRL.
I think, sorry for that. I should mention it, absolute. I think Ericsson is an essential partner in this kind of area because Ericsson is delivering the, let's say, the base for data handling and also data exchange. And I have to trust Ericsson if 5G is really functioning very well or is even modifying data or something else. And therefore, I think even Ericsson should, and also even Telecom or Telia or whoever, they also have to work together to find a common standard. And I think Ericsson is, in my opinion, even working in ITL in a better situation because they are much more closer to the technique and even on their own. But even in their community, they must think about to cooperate. But is it cooperate with competition? Yeah. And maybe they must have another ITL for data. I don't know. Yeah, but you have right. Yeah.
Okay, Håkan, you raised your hand. Ericsson.
Yeah, Håkan Schildt from Ericsson.
Yeah. Oh, you can give an answer too.
So we certainly have an interesting future with the data and 5G, etc. And I think you mentioned Telia and you mentioned the operator. So I think that is a key insight also that the operator around the world, they provide the connectivity that all of this sort of builds on. So that's really important. But I actually had a completely different question. You mentioned the software development principles, and we have a fair bit of software in Ericsson, so I'm coming from that angle now. How do you see the future for software? Because I feel that the automotive industry has sort of prioritized stability above functionality, so to speak.
Yeah.
So I didn't see a future coming where you would software upgrade your vehicle, every day or something.
Yeah.
Like you do with the PC. So what is the future there that you see?
I think it will change, but still there's being unsure if during the software update we can ensure security and we can absolutely sure that the new software is much more better. So what I recognize, when one engineer makes a modification in the software, the modification is very quick and he is convinced everything is correct. But the testing takes so much time that when he's ready with the testing, he would like to bring it up to the vehicle on the air. The methods we have implemented in the new generations, we recognized, oh, it's nice that you're ready with the testing, but I have still another modification. Okay, then we wait with the installation until we have tested the other modification. So the testing takes too much time that you will be on time on the air. And this is something which, especially in the Institute of Professor Rausch in university, we started. Maybe you have also own research here, I guess, how we can bring up the modification much more quicker, even by the customers. but even ensure the safety of the car. This is an issue really I'm feeling we have come to closer understanding. But the traditional work in the automotive industry is like that. Make an improvement, but test it consequently. And the testing takes time. Yeah. Think about every car is tested more than 100,000 kilometers. Otherwise, nobody would give a release on the road. Yeah.
Okay, we have a question.
Yeah, thank you. I was thinking beyond the lab, if you are going to implement out there, who's going to be the integrator? Is the integrator to be found within the lab and then go out there, or could, for example, the integrator be a city?
Yeah.
Becoming then a living lab where you actually start the implementation in the real world?
I think your question gives an inspiration, but I don't have an answer. But maybe you have right. Maybe you have to think a little bit out of the box and say, okay, there's also some possibilities that there are being other integrators available. At the end, the integrator should be the best, who's being the fastest, the consequentest one. But it's a good question. It gives me some more thoughts. Thank you for that. Yeah, but I don't have an answer today. Yeah.
Okay, one quick question.
Very fast. I'm Martin from Scania, Connected Services Strategy Team. Håkan Schildt, say hello to you.
Oh, thank you.
I was brought to Scania.
Yeah.
One very fast regarding Ericsson. At least from a Scania point of view, one of the key strategic partnerships for connectivity and digitalization is the CIO's collaboration.
Yeah.
Is key and it has different streams, and one of them. Regarding, it was a great presentation. Thank you for coming. I'd like to ask you, how do you see the role of these are difficult questions to answer. The role of artificial intelligence and China attached to this is threat, opportunities.
Yeah. I think I'm not so in this theme, I must say, but I know that especially one of the colleagues of this institute where I'm being now associated is working on that, artificial intelligence. The question is then, do we have, at the end, I don't have an answer, when the artificial intelligence grows up and educate themselves and we have more and more self-learning machines, the machines are much more intelligent than we ourselves. That is a risk, and we have afterwards control about that. And this is the same question at the end. We believe on that? Yes, we believe. How we can control artificial intelligence so that it will be not misused. So we need some control. You understand, that in a world where we have concrete parts and concrete methods and concrete things we can touch, we can see, we can smell, we can taste, suddenly we have something you can't get. You know something happened with that, but you really don't get, and you get grip on that. And this is my core question always. How can someone give me an instrument where that, okay, this software has a high quality and will function stable? And I don't find anyone. And I hope researchers will come together and find such a solution. We need that to get trust, especially when it comes to connectivity, especially when it comes to data awareness and reliability of data. A huge work has to be done in the future. This is a demand, it's a positive measure. The young generation will have enough work to do for your lifetime. You will not be without any work in the future. Okay.
Okay, thank you very much, Harald.
Thank you. Thank you, Jonas. Thank you.